All right. All right. Welcome to our first class. Yay, I'm excited. Okay. So in our first class, I'm going to give you what was I going to say? The disclaimer. So the very first class is all about vocabulary. And the problem with learning about vocabulary is there's not really a whole lot of exciting ways to teach vocabulary. It is not the most exciting thing. Let me tell you, the math gets pretty fun later on, and I might just be saying that because I have a degree in math and love math, but it does get a lot more fun later on. The first class can be a little dry. I'm apologizing in advance, but it is really about vocabulary because probability and statistics is its own language. We use a lot of different terms that you don't use on a normal basis. So we've got to learn the vocabulary. So chapter 1 is really about that. It's really about the vocabulary. And we're going to dip our toe in chapter 2 and do a tiny bit about 2.1. But after today's class, you will have enough information to finish the first assignment, that chapter 1 assignment. That one is the one that we use for attendance. So you'll have enough to do that. On Thursday, in Thursday's class, we will finish up chapter 2, and I will show you how to do the lab. At the end of this class, I will tell you what kind of data you're going to need for the lab. So if you want to have it ready to work on right after next week's class, you can do that. So we're going to get going. All right. So statistics, it is just the science of collecting and analyzing data, using that information to draw conclusions and answer questions. I'm going to let you know ahead of time. It kind of gets annoying at times, but statisticians don't deal in absolutes. We won't say that something is absolutely an answer. We will say something like it might be this, or it is approximately this. And so we don't, or we say it tends to this. We don't ever draw a solid conclusion. Almost everything a statistician does just leads to more study. It's science. It's a science. And science is the same way. Science has theories. They don't actually prove something beyond any shadow of a doubt. They're like, hey, this is my theory. And here, look, I'm supporting my theory, but let's keep studying it. Same thing. Stats is the same way. So it gets annoying at times, but that's what it is. So the information that we collect in stats is called data or data. I use both of them interchangeably, and it can be annoying to people, but I apologize. It just is what it is. And data is plural, which annoys me, and I probably won't use it as plural all the time because we say things like data are rather than data is, and it's just weird. So the data is a fact or proposition. We use it to draw a conclusion or make a decision. Sometimes it's numerical, sometimes it's non-numerical, but it describes some sort of characteristic. So we're going to use the data to offset anecdotal claims. We're going to use it to prove points. We're going to figure out when we're misusing it. We're going to use it for all sorts of things. And it's going to be really great because you're going to understand so much more of what you see on the news and in other places once we start learning this language. All right. So start with the basics. A population is the entire group we are studying. So it is the entire group. So if I was doing a study about, if I took a sample, took 500 American voters, and I was trying to see how voters were going to vote, the population would be US voters or American voters. So and the example here is if we were going to be presenting a study of RCC students to determine if there's a correlation between the amount of time studying and the grade received, the population would be all RCC students. So the population is the entire group. Even if we're not talking to everybody in that group, the entire group is the population. Next, we have a sample. So a sample is a subset of that population. So if I took 500 US voters, that 500 voters would be my sample. So in the RCC example, if we select 50 RCC students and use their study hours and grades for our study, those 50 students are our sample. Kind of like, you go to Costco and you get a sample. So you get a piece of a cheesecake. You're not getting the whole cheesecake. And as you go back 4 or 5 times and keep getting pieces, you've sampled 8 pieces of that cheesecake, but not the whole cheesecake. Because of course you do have to keep going by and getting more, because you never know, it might not be good anymore, to make sure that it's still a good cheesecake. So the individual is one member of the population. So it is one member, one US voter, one RCC student in our study. That is an individual. And there are definitely questions about what these are in your homework. All right. Moving on. And make sure that if I move too fast ever, you holler at me and I'll stop. I'll slow down. I don't mind at all. Okay. So we're going to show you an example of population or of statistics here. So you're walking down the street, notice a person walking in front of you drops $100. Nobody seems to notice the $100 except for you. If you could keep the money without anyone knowing, and we would be asking, would you keep the money or return it? So when I'm in person, I actually put Post-it notes in every station and people give me their answer anonymously and then I count them up. We can't do that in our class, but I'm going to make something up. So let's say I did an anonymous poll. I think we have 42 in our class right now. Darn it, I hate when that happens. I believe we have 42. If not, that's the number I'm going to decide that we have. So 42. Uh-oh, I just did it the wrong way. Sheesh. Okay, let's say I have 42 students, and let's say that 38 of the 42 students would return the money to the owner.
I did not take him because when I got home, I had to clean up his mess.
Okay, so 38 divided by 42, that gives us about 90.5%.
He did pee.
That would give us about 90.5% of our class would return the money to the owner.
He did pee. He also got into the cardboard and he dumped the cans all over the place.
All right, can you mute? I'm not sure who that is, but can you please mute? All right, so about 90.5% of our class would return the money to the owner. This is a statistic. So a statistic would be, a statistic is when we take a sample. So our sample is 42 RCC students. That sample is 42 RCC students. And so that would be a statistic. When we have a numerical summary of a sample, it is considered a statistic. So I didn't do anything with these numbers. I didn't analyze them in any way. I didn't take the statistic and say, that means 90% of all RCC students would return the money. I didn't do any of that. I didn't crunch any of the numbers. All I did was look and see what percent of our class would say they would return it to the owner. I've done nothing with it. So descriptive statistics describes the data through numerical summaries, tables, graphs. So if I summarize it, so actually this right here would be my numerical summary. If I summarize it or I put it in a table or a graph, this is descriptive statistics. You are not going to have to tell the difference between these two or say, hey, that's a statistic, that's descriptive statistics. But knowing what a statistic is important. Knowing that it refers to a sample is important. Those are the two pieces. Oh, it's okay. Sometimes the unmuting happens. All right, we're going to move on. So we described the results without drawing any conclusions. So this is descriptive statistics. I just said that. Sometimes I forget what's on my PowerPoint and I talk ahead of it. It's weird because I just looked at it today and went through it, but no matter. All right. We already went here. We had 38 out of 42, 90.5%. So if I used this and extended it to the population, this would be inferential statistics. So I'm inferring something based on a study that I did, based on my sample. So if I said that based on this, I can conclude that about 90% of RCC students would return the money to the owner. That would be inferential statistics. I'm making a prediction based on something I drew from a sample. Okay. Usually when we do inferential statistics, we'll have a level of confidence This is something that we're probably not going to be learning until like week 7 or 8, but we'll have a level of confidence. You've seen this probably in like polling for like presidents or any elections where it says like 38% vote for this person, plus or minus 3%. That is making, and we're inferring based on a sample, and that would be our margin of error. Okay. Move on. So say we can say that all our RCC students, we can say with 95% accuracy that between 85.5% and 95.5% of all RCC students would return the money. So this gives it that margin of error, or that, so basically would say that means that the actual number is probably between those two numbers. We're 95% sure that it's between those two numbers.
And sorry, I just have a question.
That's okay.
The 85.5%, is that, are you just going, 10 plus down from the 95?
I just went 5 down from 90.5 and then 5 up from 90.5.
Okay.
I just decided that my margin of error was 0.05, but I mean,
Mhm.
I just picked a random number. It's really,
Okay.
but it'll be the same distance above and below.
Okay.
Yeah, but it was just totally random. It's just,
Yeah. Thank you.
You're welcome. All right, moving on. Okay, suppose that the percentage of all students on our campus who have a job is 84.9%. This is a parameter. Because it's a numerical summary of a population. I'm going to give you both statistic and parameter on the same page in just a second. So because this is a population and I'm giving a numerical summary of the population, this is called a parameter. You will be required in your homework, and I'm thinking probably on the test, which is still a few weeks away, to tell the difference between a parameter and a sample. And a statistic, sorry. So suppose now we have 250 students that we took a sample of, and from the sample, we found that 86.4% have a job. So this is a statistic because it's based on a sample. So there's the difference there. One of them is we poll all students and find that all students, 84.9% have a job, but this one is just based on the sample of 250. So here's the two things on one page. A statistic is a summary of a sample. Parameter is the summary of a population. I'll give you a second to write it down, then we will move on. And something I didn't mention at the beginning of this, I mean, I mentioned it somewhere else. Most of our classes, most of our Zoom meetings will only be about an hour, max an hour and a half long. Could go slightly longer if there's a lot of questions, but I don't want to hear myself talk for 2 hours or 2.5 hours. And I figure you guys probably don't want 2.5 hours of lecture. So usually what I do is I will have class for about an hour to an hour and a half. And then I just try to make myself available via messages and emails and things like that afterwards as much as possible. So that way, and you guys will have, since you already set that hour or so aside for yourself afterwards, you just work on the homework, and then I'm available to answer questions via emails and messages and the discussion. So usually 6:30, 6:45, most of the time you'll be done on the Zoom. Because I mean, can you imagine sitting through 2.5 hours of lecture of math? That doesn't sound like fun. Not for anyone. It's not fun for me. I don't want to hear myself talk that long. All right, moving on. Maybe. Okay, the goal of inferential statistics is to use statistics to estimate parameters. So use a sample to estimate the population. That's not important. It is important, but you don't have to remember that. And I will moving on up. All right. Once again, this process of statistics, this just kind of gives you an idea of how statisticians work. You will not be required to recall this process. I just want to kind of tell you how things work. Number one, The first thing we do is figure out what question are we trying to answer? Because why would you start collecting data if you don't know what you want to use it for? Because usually we figure out, okay, what question are we going to answer? And then you think about, what do I need in order to get that question answered? So figure out, what is my population? What is the question I want that population to know about that population? That's the research objective. Next, collect your data. So you figure out what your question is. Okay, what data do I need? Then you figure out a way to collect it. We usually don't question an entire population because most of the time, doing research on an entire population is too expensive and it's time consuming. So then we'll need to take a sample. Later on, I'm going to show you how to calculate what an appropriate sample size is in order to get the type of answers you want. But currently, we're just going to talk about, let's just collect our data. When it says if the data isn't collected correctly, what that's referring to is it needs to be random. We need to randomly select, because if we're not collecting random, then you're going to end up with issues. Next. Oh, wait, here we go. This talks about the non-random samples. So there's a lot of studies that are convenience samples. You've all probably seen these: internet surveys, phone-in polls, things like that. So think about, let's say that, I always like to use politics. Let's say that the question is Joe Biden doing a good job as president? Let's pretend that that's the question. If I post that question on foxnews.com, I'm going to get very different poll results than if I post it on msnbc.com. I'm going to get very different results because the audience that is in those places are they have very different political views. So samples like that cannot be used. Those are not reliable sampling methods. Same thing with phone-in polls. So you think about back in the days when with American Idol, you'd call in and you'd vote for people. You didn't tend to call in and vote unless you really liked somebody or really had strong feelings about it. And same thing with any kind of thing. People are not going to call in and vote on like something about, say, like, is the school district doing a good job? Unless you have a really strong feeling one way or the other, you're probably not going to call in. Some of those used to be like 99 cents to call in. So you'd really have to feel strongly to call and spend $1 to call in. All right, moving on. After you collect your data, then you need to describe your data. You're going to do all sorts of math and analysis and things. This is where you're doing that. Once you do all of this math and you apply your statistical methods to it, then you can describe what you found with your data. You can usually you're not drawing a conclusion yet. Usually you're just saying, here's what I found. And then the last thing you're going to do is you're going to draw your conclusions. You're going to say, based on this study, here is the conclusion that I'm making. Now, most of the time you will say that, like, for example, it would say, like, based on this sample, I can determine that about between 82 and 85% of all RCC students have a job outside of school. Now, most of the time, I mean, they might accept that and say, okay, that seems pretty accurate. But if they're trying to nail things down even more, if they want something more accurate, they're going to do another study that, again, they tend to just keep restudying and restudying the same things. And like a lot of times they're like challenging their previous results, and just over and over and over again. It is a never ending cycle. So being somebody who crunches numbers, you probably could make some pretty good money because your job's never over. All right. Any questions on this so far? Are we doing okay? All right. So we're going to see an example of a study, and I'm not going to just read this. I'm just going to kind of tell you the study because this is a lot of words. This is like a big wall of words. So this study was about batterer treatment programs. So people who, it's specifically for male batterers, male defendants who battered their who assaulted their intimate female partner. So domestic abuse between male and female, where the male was the person who assaulted the female. So they're trying to figure out whether community service or a treatment program would keep the men from battering again. So what they did was they took 376 male criminal court defendants and they split them in randomly into two groups. So notice it says randomly assigned. That's really important that they were randomly assigned into two different groups. One was a treatment group and one is a control group. The treatment group was in a 40-hour batterer treatment program. The control group got 40 hours community service. After 6 months, 21% of the males in the control group had further battering incidents, and 10% of the males in the treatment group had further battering incidents. So these researchers concluded that the treatment is effective with reducing repeat battering offenses. So this is what they conclude. Go ahead.
So the control group is the group of people that didn't have any, like, I always get that confused, and even in other science and math classes, the control group is the part
No
that
treatment.
no treatment.
Right. So community service was the basic thing that they sent these men to do. This was like the normal. So the control group is the one that keeps doing the normal thing that we always do. So for example, if we were trying to determine if a certain headache medicine was effective in reducing headaches, we would give, the control group would get a placebo. So they would get like a sugar pill, and then the other group would get the headache medicine. So the control group is the one that doesn't have the treatment. Does that help? Okay, good. All right, so let's break this down. So first thing, we need to identify our research objective. So we're trying to determine whether the people in the treatment program are less likely to batter again compared to those with community service. So we're trying to see if this treatment program is effective. That is our research objective. So we haven't done any kind of treatment or done anything yet. We're just trying to see, is it effective? Next is where we collect our information. Here's our information that we need. We took however many men it was. Group 1 was in a batterer treatment program. Group 2 were in community service. 6 months after, we determined whether or not they battered their intimate female partner again. So we still have not crunched any numbers. All we did was collect the information. This is how the program was done. Number 3 is where we do the math. So after 6 months of treatment, 21% of males in the control group had further battering incidents, while 10% in the treatment group had further battering incidents. We have not drawn a conclusion yet. All we've done is state what came out of our study. Lastly, we'll do the conclusion. The conclusion is we extended the results of the 376 males to all males who batter their intimate female partners. So we feel, based on this study, that those who are in the batterer treatment program are less likely to batter again. Now, most likely what they would do is they would say, okay, continue to study what happens with these people. Because also they could say, oh, that's only 376. That's such a small percent. Let's take another 400 people. Most of the time, a good study leads to another study. So that is how we break that down. You are not going to be required to break apart one of these things into pieces. It's just so you get the idea of the process. So don't worry, you don't have to break it down. I usually try to say, hey, you need to remember this, or hey, put a star on this. This is really important. I try to do that when possible, but I mean, obviously it's not always going to work, but I try to do that. Okay. More vocabulary. Ooh. So we're at 6 o'clock. We'll probably get done in a half hour-ish. Yeah, we're doing good. Okay. More vocabulary. Variables. I know you've been doing variables for a very long time in all of your math classes. It's kind of the same thing here, but variables aren't just numbers. They're the characteristics of an individual. So if you were sampling Skittles, the variable could be the color of the Skittles. So it's just, that's what the variable is. It's the thing that varies. So if everybody had all the same height or plants grew exactly the same, we wouldn't need to study anything and We wouldn't need variables. Variables vary. So that's basically it. Next, qualitative or categorical. So most of the time I use the word categorical rather than qualitative. I think My Open Math does both. They mean exactly the same thing. A good way to remember qualitative is that it's about qualities. So it's qualities like left-handed, right-handed, brown hair, blonde hair, things like that. It is based on some attribute or characteristic. Most of the time, it's not numbers. It's only numbers if it's not numbers you do math with. Like, for example, a phone number, we would consider that categorical because you don't do math with a phone number. I wouldn't say, oh, my phone number is twice your phone number. It's just weird. So we don't, we don't do math with it, it could be categorical. Otherwise, it's words. Here's some examples. Gender, zip code, hair color. Birth date is kind of iffy. It depends on what you mean. If you just say, I was born in April, then that's more qualitative. But if you're specifically saying, oh, he was born 3 days after me, then that would be more quantitative, if that makes sense. So if it's numbers you're not doing math with, or that you're not planning to do math with, then it would be categorical.
So sorry,
No,
like so
apologize.
situations like that. So if you're looking for, like, if what you're looking for is a specific population that was born between like 1980 and 1990,
Mhm.
then you could use the birthday. Like if it was April to, July of 1990, then you could use those. But otherwise, that's just qualitative information, right?
Right, exactly.
Okay.
Good,
Okay.
yes. All right, so next, we have quantitative data. So think quantity. That's how I always remember it's quantitative, is quantity. This is the numbers. This is numbers you will do math with. It's going to you add or subtract them, and they provide meaningful results, because adding your zip codes together does not make sense. So it's when numbers provide meaningful results, when you can do math with them. Temperature, number of days a student has studied, height, weight, things like that. Anything that you would do math with. I would not do math with a phone number or a zip code. I mean, there's some things that are just like, that's just silly. I wouldn't do math with a street address, but temperature, number of days. So anything that is meaningful as numbers would be quantitative. Any more questions about this before I move on? Doing good? Okay. Alrighty. Let's look at some examples. So this researcher, Elizabeth Kavavic, I think that's how you pronounce it. If not, that's how I'm pronouncing it. She studied factors about eating habits of adults in their mid-30s and we're going to classify the variables that were considered in the study as quantitative or qualitative. So nationality, quantitative or qualitative. So I mean, if you're nationality, you're not going to do any math with nationality. So that's definitely qualitative. Number of children, I can do math with that. I mean, I have 4 children. I have twice as many children as my youngest daughter. That would be quantitative. Household income in the previous year. Oh, we all are doing math with our income. All of us. Mostly subtraction. That's quantitative. Now, this one's tricky. Level of education. So when I think of level of education, the first thing I think of is things like I have a bachelor's degree or a master's degree, or getting my PhD, a high school diploma. That makes it qualitative. However, if you are saying it's been 2 years since they were in 4th grade, she's in 4th grade, she's 2 years higher than he who is in 2nd grade, that could be quantitative. It depends on what you're doing with it. So you have to really think about that. What am I doing with it? I'm not going to ask you questions that are that iffy. If we're on a test, I might give you number of children or nationality. I probably wouldn't give you level of education. I'm not going to give you something iffy like that. I would probably try to make sure that it's clear. It's clearly quantitative or clearly qualitative. That would be rude. And I try not to be rude. Okay, daily intake of whole grains measured in grams per day. We all can measure our whole grains, so it's quantitative. Does it all make sense? Any questions? All right. So glad you're all still hanging in there. So discrete and continuous. You may remember, I'm trying to remember if it's math 60 or math 65. I think it might be 60, where we talk about discrete and continuous. I could be wrong though. So discrete and continuous. So discrete has either a finite number of possible values or a countable number of possible values. So these numbers will not take on everything in between. So an example of discrete is how many children someone has. I have 4 children. Someone else might have 2 children. Someone else might have 3. You're not going to have 3.876 children. Now, we're not talking about pregnancy and that weirdness of pretending you have, 3 1/3 children because you've been pregnant for a certain, 3 months. We're not talking about that, but it is discrete. So here's some, cannot take on every possible value. Here are some examples. Number of students in class, how many TVs sold last week, number of red marbles in a jar. So if I was graphing this on a number line, if I was graphing this on a number line, I'm going to make my pretty number line here and change my color because it's fun. It would be dots on a number line. It would not be I'd have to lift my pencil to graph every point. It's not going to be continuous all the way through. I wouldn't be able to have this value right here. It's dots on the number line. I mean, sometimes it's not countable numbers like 1, 2, and 3. It could be something like every t-shirt costs $5.50. So if I buy 2 t-shirts, I've spent $11. So you're going to would have $5.50, $11, $16.50. It's going to jump $5.50 every time. You're not going to get every number in between. You will never have $12.75, if that makes sense. So it's just has a finite number of values. It cannot take over every value inside. Then we have continuous. Has an infinite number of possible values. It's not countable. So it can take on every possible value between 2 values. Time is one of them. I could not have been waiting 5 minutes if I wasn't waiting 4 minutes and 56 seconds. And I know that earning money is kind of weird on that because you can do pennies and a lot of people round up to the nearest 15 minutes or something, but technically money is considered continuous because you have to earn $14.75 before you can earn $15. So earning money is considered continuous. Here's some example. Height of students in class, time it takes to get to school, distance traveled, weight of a baby. So I had to be 5 feet 1.5 inches before I could be 5 feet 2 inches. So height is continuous. So if I was graphing it to get from this point to this point, once again, I'm going to change colors because it's fun. I had to take on every single point in between to get from one point to the other point. If that makes sense. Any questions on discrete and continuous before we look at examples? All right. Uh-oh, I didn't realize, forgot I had that little graphic there. So quantitative variables are discrete or continuous. Qualitative variables are not. You will be asked in your homework to determine, and I believe on the test even, to determine if things are discrete and continuous. Which one is which? I believe. Since I changed the test a little bit every time, that's why I say I believe, because every single term I change it a little bit. And I haven't gotten that far yet. All right, moving on. So we're back at Elizabeth Kvavic and our eating habits of adults in their mid-30s. So we're going to determine whether they're discrete or continuous. I already kind of told you on this one. Number of children. I'm not going to have partial children, so this is discrete. Household income in the previous year. It's again, money. We always consider money to be continuous and when you're earning it. So this would be continuous. Daily intake of whole grains measured in grams per day. Yes, it's measured in grams per day. They're probably not doing partial grams, but a gram is pretty small. So you have to still eat 3.6 grams before you can eat 4 grams. So we consider this continuous. Questions on these? All right, good. Levels of measurement. I'm going to give you the normal, the disclaimer that I always give for levels of measurement. Occasionally, this is a little bit confusing, and this is an area that students frequently struggle. I believe there's a couple of homeworks on the question, and I believe I have one 4-parter on the test, but I'm going to give you my tricks for remembering these things and what to look for first. So I'm going to do what best that I can to give you what you need to memorize them. And you can use notes on your test. So just make sure you have these notes and it should be fine. So levels of measurement, we have 2 of them that are discrete and 2 of them that are continuous. And the 2 are, nope, I just lied. 2 of them that are qualitative or categorical and 2 of them that are quantitative. Sorry about that. All right, so nominal level of measurement. This is basically, it's a label that categorizes things, and they are not ranked by order. We don't care order. So basically, order doesn't matter. So it is nominal if it's a categorical variable. And so basically some examples of things that are categorical. Whoops, I don't know what's going on here. So gender, male and female, we don't order those a certain way. It's not going to change the meaning or anything by ordering them. Left and right-handed, you don't order those. Religion, order doesn't matter if you're listing them out. Same with favorite color. Order doesn't matter when you're listing them out. They're just labels with no specific order that they need to be listed. This is just nominal. This is kind of our lowest level of measurement, lowest level of organization, and order doesn't matter. And the next one, it's kind of convenient that the word order is practically in the word. Ordinal level of measurement. This is also generally categorical, and it's similar to nominal. However, order does matter. It matters which order you write it. You can rank them or put them in a specific order that makes sense. So I'm going to write that down here. Order matters. So order matters. This is important there. So some examples, grades. So we have grades A, B, C, D, and F. Satisfaction. Satisfaction is kind of like one of those things where it says extremely dissatisfied, satisfied, neutral, or extremely dissatisfied, dissatisfied, neutral, satisfied, and extremely satisfied. That's kind of what I mean by that. Happiness can be the same thing where it has like the extremely unhappy all the way up to happy. Some other things would be like levels of education or the way you go through school, elementary school, middle school, high school, bachelor's, master's, all of that, like those could be ordered. Any categorical thing that could be ordered, that would be the ordinal level of measurement. Right. The next 2 are quantitative, and I'm changing colors just for fun. So first one is interval. So here is the part that's going to help you. 0 doesn't mean absence of quantity, plus the math that you do with it, addition and subtraction. So the math you would do with these measurements would be addition and subtraction, and 0 doesn't mean absence of quantity. So whenever I'm looking at a quantitative thing and I'm trying to determine the level of measurement, the first thing I determine is, does 0 mean absence of quantity? Here's some examples. A 0 degrees does not mean there's no temperature. It just means it's really cold. I can still go down to negative, and that still makes sense. 0 doesn't mean there's no temperature. Just like 0 in calendar years, the year 0 doesn't mean there's no calendar. I don't know. There's not no more years. It just means that we don't, I don't know, we go to BC before that. Elevation, a 0 elevation does not mean that we don't go anywhere. We can't go down more. There's no absence of value. 0 elevation is just sea level. So it kind of makes sense. And then looking at the addition and subtraction, I would not say it's twice as hot today as it was yesterday. I could say it's 5 degrees hotter than it was yesterday. Same with calendar years. And that was 1979 was twice as many years. I don't even know how to explain that. I don't even know. Elevation. I mean, I guess you could say it's twice as high above sea level, but that doesn't really make sense. I might say it's 100 feet higher than something else. It just, addition and subtraction is the math that makes sense with this. All right, let's look at the last one, ratio. Ratio level of measurement. A value of 0 means absence of quantity, and the math you do is multiplication and division. So here, 0 does mean absence of quantity. Multiplication and division are math that you can do with it. So let's look at our examples. Money in your pocket. If I have $0 in my pocket, there's nothing in my pocket, just lint. I can say I have twice as much money as the person sitting next to me, or I have half as much money as I did yesterday because I spent some of it. Does that make sense? Height in feet and inches. Absence of quantity. 0 would mean absence of quantity. It kind of doesn't make sense at all. If something's 0 feet tall, there's nothing there. I mean, you can say that that fence is twice as tall as the other fence. I guess you could do that. That math works, multiplication and division. I want the fence in front to be half as tall as the fence in back. Makes sense. Weight in kilograms. If I have no weight, there's nothing there. Same thing with time spent watching TV. If you didn't spend any time watching TV, if you have 0 hours, you didn't watch TV, there's no quantity there. And I can watch 3 times as much TV over the weekend than I did during the week. That makes sense. So multiplication and division, and 0 means absence of quantity. Questions? So that's what I checked first. And we're going to do look at a couple of examples here. I probably already gave the answers to them because I do that sometimes. So which level of measurement? First, gender. We already kind of gave this example. Gender is not ordered and it is categorical. So it would be nominal. Temperature. So with temperature, we check, does 0 mean absence of value? No, it does not. Do I do multiplication and division with it? No, I do not. Interval. Number of days a week a college student has studied. This is numerical, it's quantitative, sorry, it's quantitative. So it would be either interval or ratio. And 0 does mean absence of value, therefore it's ratio. Lastly, letter grade earned in stats class. You can put those in order, and it is qualitative, therefore it is ordinal. Does make sense? Feeling groovy? All right, all right. We're almost done. Probably we're really close. Okay. We're if you keep track of this sort of thing, we're now jumping into section 2.1. We just finished chapter 1 and you survived. I don't believe there's a whole lot here. Now it says there's 14 more slides, but trust me, some of them are really fast. So take a deep breath. If I was going to talk for 2.5 hours, we'd take a break, but we have maybe 10 minutes left. So I'm hoping y'all can survive another 10 minutes. But you're at home, so you can always get up and go get a drink of water or go to the bathroom or something, and it's good. All right. So remember, qualitative data, categorical data is, we categorize it, classify it individual, usually it's words. So this is new. A frequency distribution lists our categorical data and how many times it occurs, how frequently it occurs. This is a frequency distribution. So if I ask you to create a frequency distribution, you would list each one of the values of the variable or each category of the data, and then list how many times it shows up. I will show you what this looks like. Okay. Before we do that, this is an important word, raw data. Raw data is data that has not been cooked yet. So basically, once you collect all your data, before it's organized or before you've done any kind of analysis at all, you haven't even counted anything yet. Before you do anything, it's just raw. If I was taking Skittles out of a bag, I'd be like, orange, green, yellow. You're just writing down those numbers or those words right in order. That's raw data. You have not cooked it. It's just a list. You'll see it in a second. Then once we order that data, once we cook the data, we can put it in a table or graph or numerical summary. That is after when it's no longer raw, we've cooked it. All right. On the next slide, I'm going to show you some really annoying raw data. And it is a bunch of M&Ms from a bag. It's completely raw. Basically, as I took them out of the bag, I put down brown, brown, yellow, red, 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 and on and on. This is completely raw. It has not been cooked. And it's kind of not fun to look at. Thankfully, you don't have to do anything with it. I already did. This is my frequency table. You don't necessarily need to show me the tally marks. I just showed you how I counted them. As I counted the brown, I put in the tally marks, and then I put how many tally marks I had. The frequency is how frequently it shows up, how many times I had each one of those. That is the frequency. So the frequency table. So all you're doing is counting each one and just writing down how many you have of each one. All right. Make sure you holler at me if I move too fast. I'm going to move on. So relative frequency. So we use relative frequency to kind of, so if I have two different bags of M&Ms, they're probably not going to have the exact same number of M&Ms in them. So if we convert them to relative frequency, then we find the proportion or percent that of each color, and it's easier to compare two things that may not be exactly alike. So we're finding the proportion in each category. So in order to do that, you would take how many total M&Ms do I have? And over top of that, I would put how many times did it show up. So I would put how many times I had brown M&Ms over the total number of M&Ms that I have. And we can make a relative distribution list the same way that looks kind of the same as the frequency, and you'll see it in a second. So take the number of that particular category divided by the total number of items that we have. That's relative frequency. And I'll show you with the M&Ms. All the math is already done for us. I love when that happens. So the relative frequency, I took 12 M&Ms and I divided it by 45, and I got 0.2667. So about 26.67% of my bag of M&Ms was brown. Took 10 divided by 45 for the yellow. So about 22.22% of my bag of M&Ms was yellow, and so on and so forth. So this would be a relative frequency distribution. I'm going to write that. Whoops. Or relative. I hate when that happens. Discard. Okay. This is a relative frequency distribution. That's what that is. So if and you don't have to have, if you left this part out of your relative frequency distribution, that's okay. You can leave it in, you can take it out, it doesn't matter. If you want it to be relative frequency, if you just had those two, you're good. All right, moving on up. So a bar graph, you probably have seen millions of bar graphs in your lives. So a bar graph, we label each category of data on the horizontal, usually the horizontal, occasionally the vertical axis. And then the other axis will be your frequency or relative frequency. All the rectangles are equal width, and the height tells us how frequently a number came up. So I'll show you what that looks like with M&Ms. Just a second here. So here is my frequency, my bar graph for M&Ms. So remember I had 12 M&Ms, brown ones. So my little bar here goes up to 12. Make sure when you are creating a graph that you label both the horizontal and the vertical axis, and you need to have a title up there. Make sure you are labeling. You will lose points for not labeling. So if you create a bar graph, you're not going to be creating bar graphs by hand. You're going to be creating them in Excel. That's part of the lab that we're going to do. So, but make sure you put labels on them. So this tells me that it's the color of the M&Ms on the horizontal and the frequency on the vertical. And it just makes it all nice and pretty. So it's not raw. It cooks my data. I'm going to make a relative frequency bar graph here in a second. And you're going to see that it basically looks exactly the same, but instead I have the proportions on the side, or those relative frequencies. This, the relative frequency, as I said, it's helpful when you're like comparing two different bags of M&Ms. It's also helpful if you wanted to like go onto the Mars website and see how closely your proportion matches up to what they say it should be. I think this is pretty close. I feel like I remember researching this or looking it up to see how close it was. And I think this was pretty close. Any questions so far? We're doing good. We're almost done. We are on.
I actually have a quick question.
Yes.
Does it matter if we put the color on the other side? I mean,
It
how
really
do we know?
I mean, it doesn't really matter if you did color here, if you did color here and frequency here,
Uh-huh.
and then you'd make your bars go like this. You'd have to make your bars go like that. And I mean, it's just a style choice. But you have to make sure that your bars are going the correct direction for the way you do it. But
Okay,
most,
why is that? How did you get that? I mean,
how did I get what? What do you?
oh, I see, because your colors would go. Okay, yeah, you're right. Thank you.
You're welcome. Good. All right. Last thing. This is the very
Not
last.
the only one.
You're okay? Are you good now, Kylie? Do you need me to go back?
There's a lot of math going on right there. So
There is, and we're almost done. I've got one tiny little thing, and you probably will never again hear about it. I don't even think there's a homework questions about Pareto charts, but it's in the standards and we're supposed to teach it. So you're going to learn Pareto charts, but I don't think you're ever going to hear about them again or see them again. Or you might see them, but you won't care what it's called. The only thing about a Pareto chart is we order it so that the highest frequency thing is first, and then it steps down. So take a look here. So I just put them in order, largest to smallest. And that is the only difference between a Pareto chart and a regular bar graph. See this bar graph, it's all over the place. And I don't know where blue went. Don't ask me. I don't know where blue went, but it just goes from largest to smallest. That's a Pareto chart. And I
don't see the difference.
take a look here. Notice how it kind of goes like this.
Oh,
And then here, it just goes like this.
okay. Thank you.
You're welcome. That's the only difference, is it goes largest to smallest. And trust me, it will not be on a test. I am 99% sure it's not on the homework assignment. I will probably never mention it again until I teach this next term. But it is part of the standard.
or just the Pareto chart?
What was that?
The charts like in general, charts in general, or just the Pareto chart?
Just the Pareto chart. Bar graphs are very, very important, but the particular Pareto chart, it is just one of the things we're supposed to teach, but it's nothing that I've ever, I didn't even know what it was until I started teaching this class. I had never heard of a Pareto chart, so I started teaching this class. And basically, this moment is the only time I mention it the whole term. So just, I have to mention it, so there it is. There you go.
Right.
Okay, so we're currently still in recording. Are there any questions you would like to ask while we are still recording? If not, I'm going to stop recording it in a minute and then you can ask off the record questions. Anything that you want to ask for the good of the group? All right, I'm going to stop recording.